Hello, mathematicians. Here is our Wednesday key for week 15. We start with thinking about vampire skate building. It is currently one-fifth complete. It currently is 6 meters tall. How tall will it be when it's complete? Well, if it's currently 6 meters tall, and that is only one of the 5 sections, or one-fifth complete, I really am going to need 5 of those. So 6 times 5 equals 30. It will be 30 meters tall when it's completed. Now let's go to question 2. Write an expression to find how much of the square is shaded. Well, when I look at this, I need to analyze or look for those factors. I could look this way and count how many rows do we have. Well, we have 1, 2, 3, 4, 5. That tells me that my denominator here is 5. There are 5 rows. Now, shading exists in 4 of those rows, doesn't it? That's my numerator. Sure, it doesn't continue over here, but it's showing me where the overlap is. 4 of those rows have shading. I need to do the same thing, thinking about it vertically this way. When I look at it this way, I also see that there are 5 columns. 1, 2, 3, 4, 5. And 4 of those columns right here have shading. Again, that shading could continue over here to show those entirely shaded fashion. But really, boys and girls, this is where the overlap occurs. This is where the answer is. I can look and see that this array is really a 4 by 4 array, or I can count it off and find that there are 16 rectangles that have the overlap shading. Out of how many total rectangles are in the entire shape? 25. My answer is 16/25. Now let's come down and let's think about a famous buzzer beater brownie. LeBron James has 1/2 of a tray of those famous brownies. So imagine, boys and girls, this is half of the tray, right? He eats 1/3 of those brownies. Here is the 1/3 of a half that he eats. How much of the full tray does he have left? That is what we're thinking about here, right? So here he has a half of the tray. He eats 1/3 of the brownies. If we're thinking about how much is left in all, right? Maybe this half belongs to somebody else, but it's still there, right? He didn't eat that. Really, this has 6 total pieces to the brownies. And when I look at it, he ate 1/6 of the tray. When I think about how much is left, maybe this one is left, this one is left, this one, right? There might be 5, 6 that are left. It looks like he ate 1/3 of the half. Draw a diagram to show your work. Here is an example of what that diagram might look like. Okay, let's go down to the very last one. Fill in the blanks below to make the largest product possible. Notice these are the only numbers that I can use. And it didn't tell me that I could only use them once. So the best way to do this is to get the very largest numerator that you can possibly get by plugging in the 2 biggest numbers being multiplied together. 9 times 9 is 81. In order to make this the largest that it can be, I now want to do the opposite for the denominator. My denominators, I want to use the smallest number 2 times. 4 times 4 is 16. Notice, boys and girls, this creates the very largest improper fraction that I can get, because the larger the numerator compared to the denominator, the more parts I have, right? So my answer here would be 81/16. This is our key for the Wednesday.